Chapter 14, DC circuits. Let's look at the important circuit diagrams that you need to first draw. Number 1, a switch. Okay, straight line, 2 dots. This is an open switch. This is a closed switch. Next, a battery or a cell looks like this. You can have more than one batteries. Next, let's look at light bulb. Cross. A fixed resistor, just a block. Variable resistor, a block with an arrow. A fuse, a ammeter, capital A. A voltmeter, capital V. An earth connection. So these are the important ones that you need to know how to draw. Next, let's look at a series circuit. Okay, let me redraw this diagram at the bottom. So a series circuit looks like this. The battery and maybe 2 resistors in series. So we call it in series, side by side. Okay, so what do we know? Current at any point of the circuit, capital I, okay, is the same. So current at any point is the same. I equals to I1 equals to I2 equals to I3. In the series circuit is always the same. But the sum of the potential difference from each of the components, such as the resistors, is an addition. So, as we know, this is the EMF of the battery. We can call this voltage 1, voltage 2. So, EMF is equals to voltage 1 plus voltage 2. So, if there are more resistors, we can just add them up together. So, for resistance, the formula will be R, total resistance with a small letter t, sorry, a capital letter T, equals R1 plus R2. R1, R2. Okay, if there's more, you can just add them up together. And that's for series circuit. Let's look at the parallel circuit. So let me redraw a parallel circuit for you. The battery, you can have one resistor, another resistor. Okay, so they are in parallel. First of all, for a parallel circuit, the current now is not the same throughout the circuit. So I have the current here, call it current 1. Okay, it will, at this branch out into 2 different currents, current 2, current 3. And after which, they will join back here, current 4. So I1 is actually equals to I2 plus I3, which then later join back equals to I4. Next, we look at the EMF. This time, the voltage 1 and the voltage 2 are equal. So EMF equals to voltage 1 equals to voltage 2 for parallel circuit. And finally, the resistance. R1, R2 is slightly different. RT, 1 over RT is equals to 1 over R1 plus 1 over R2. So you see the difference between parallel and series circuit. Next, let's do a quick example for parallel circuits. So in this example, we know that the EMF is equals to 6 volts. The resistance 1, resistance 2 is 10 ohms and 20 ohms respectively. Using the formula, Ohm's law, R equals to V over I. Okay, we can calculate the I1 first. So we can calculate I1. Here, I1. So R is 10 ohms. Voltage, which is the EMF here, 6 volts over I. You get I1 equals to 6 divided by 10, which is 0.6 ampere. Using Ohm's law again, R equals to V over I. Same thing, let's look at I2. Now resistance is 20. Voltage is the same, as you know. The EMF, 6 volts here, means 6 volts here, means 6 volts here. So it will be 6 over I2. I2 will be calculated 6 divided by 20, 0.3 ampere. And we know the properties of a parallel circuit. I3, which is this. Okay, it will combine, it will split out to I1 plus I2. So I3 equals to I1 plus I2, which is equals to 0.6 plus 0.3 amperes, which gives me 0.9 amperes. For I4, it's actually the same because it combines back up. Okay, let's look at another example of both in series and parallel. So you can see that there is a 3 ohm resistor and a 6 ohm resistors in parallel. So let's solve the one in parallel first. 1 over R is equals to 1 over 3 plus 1 over 6. Okay, which gives me 1 over 2. 1 over R equals to 1 over 2. R equals to 2 ohms. So I can redraw the diagram as this. 2 ohms, 4 ohm. See the diagram like this. And now since it's in parallel, it's much simpler. R is equals to 2 plus 4 equals to 6 ohms. Done. One other example. So in this case, it's easier if we solve the series first. So R equals to 3 plus 4 equals to 7 ohms. So I can redraw it as 7 ohms. And now it's a parallel circuit. 1 over R, formula 1 over R equals to 1 over 7 plus 1 over 6. Okay. And finally, the answer will be R is equals to 3.2 ohms. And that's all for this chapter.